experiment. If the total amount of solution in the vat is 2401, what is the probability that 80 drums can be filled without running out? Okay, so this time our sample size has changed. So let's take a note of that. Now we're not taking 50 drums, we're taking 80 drums. And we can change our notation a little bit. Our n is changed, so we're going to just change up a little variable. So my model is going to be normal 80 times our mean, which was 30.01, and 80 times our standard deviation, or our variance, we could say. All right, so now we have n is okay, so we have our model, and the question is asking, well, we gotta kind of interpret it, how we can formulate this question. So we want to know, we have this amount, and so what we're interested in is what's the probability that this amount is enough to fill 80 drums. In other words, that the sum of 80 drums is actually going to be less than this. Okay, because if the sum of 80 drums is less than this amount we have, then we'll be able to fill them all. So let's reformulate it like this. We want to find that what's the probability that this sum of 80 drums is less than 241. Okay, so now we're just using our normal curve, and we're just calculating z-score as we have done before. So let's do that. In this case, this has changed up here, and be careful here. So I'm using the variance version here. So you want to take a square root. Okay, let me fill in my mean here, 2400.8 over, when we're filling in the standard deviation, if I'm using this variance form like I am here, I need to take this little step here, and let's go to our calculators. And my calculator is telling me that this gives me a z-score of 0.228 approximately. And then when I go to my table, I find that the probability that a z is less than this value, then my score is approximately 0.587, which means that this is approximately 58.7% probability that I'll have enough drums, or that I'll be able to fill 80 drums completely before running out. Okay, let's look at one more variation of this. How much solution should the vat contain so that the probability is 0.1? And we're still using 80 drums, and we're still concerned about filling them all up. Okay, so what has changed here is that we no longer, so before in the last question I put a probability that Sn is less than something, and less than some value that they gave us, a fixed value. Now we don't know, now that has become our variable. So how much solution should the vat contain? Before they gave that to me as the 2401, now they're asking me for that. So what I'm going to do, since I don't know that, is just make it as a variable. So this is what I know so far, but they had to give me some more information because this isn't enough to go on. So they did give me some new information, and they want this probability to be 90%. And I have a little more information. This was, we said this before, this is still using the same sample size. All right, so we can, so again, we can use our same distribution from before for S of 80, and that is a normal with these values. And it's now, okay, so I'm going to introduce a little new notation here that we're going to use going forward. It's actually not necessary at this point to use this notation. When we did normal curves before, we didn't use the notation, but sometimes you'll find that it's useful. And that is, when I want to find the 90th percentile or the 0.1, I can refer to little z subscript 0.9. And what that means is I'm trying to find the 90th percentile. So I'm going to look on my chart, and I'm not going to look at the column and the row at the top of the row or the left of the columns. What I'm going to do is just look on the chart itself for values that are really close to 0.9. And when I do that, so I go to my chart, and I find that when I have a z-score of approximately 1.28, that's going to give me about 90%. Okay, so this is what my z-score needs to be. And this is just some notation to describe specific z's of certain percentiles. Okay, in fact, it doesn't have to be a percentile. It could just be any value of the probability that z gives you. All right, so I have this, and I can go to my equation now. I just have different things I know. I now know what the z-score is going to have to be, but I don't know what the value here is going to be. I do know the mean, and I do know the standard deviation. Okay, so at this point, it's just a little bit of calculus. A little bit of algebra and a little bit of calculator work. And all right, so we get a value of, if I have my VAT this much, if the VAT has 2,401.8 liters, then you have a 90% probability to fill them. Okay, some final notes, some comments. So the key step here, the key new step is always modeling here. You can use the model with the sum, or you can use, in many cases, also the average, the mean, the sample means. Both cases, the new step and the important step to know from the central limit theorem is that you can translate these things, their distributions, into normal curves, and then use your knowledge of normal curves to find probabilities, or given probabilities, find values.